lecture we will study the LC oscillator. Now in the last class I have explained the block diagram of LC oscillator, which consisting of amplifier and tank circuit. If the tank circuit Z1, Z2 both are the inductors, then that is called the, if Z1 and Z2 both are the inductors, then that is the Hartley oscillator, and Z3 is both Z1, Z2 are L and Z3 is a C, then it is a Hartley oscillator. Now in this lecture first let me explain about the Hartley oscillator. Now for that, how to draw the diagram. Now this is the Hartley oscillator. So for that first we need to draw the amplifier. Now here I am taking the NPN transistor. Now arrow mark should be outside. And this is the base. Now here we are using the voltage divider bias by using the two resistors R1 and R2 and capacitor. Now here we can use at the collector we can use the resistor or choke, both can be used. So if we are using the choke or resistor, both can be used for the load current RC, and here I am using one more resistor for the negative feedback purpose, and across the RE one capacitor, bypass capacitor to bypass the AC components, to bypass the AC component to the ground. Now here I am using one more capacitor, coupling capacitor. Input side also I am using one coupling capacitor. Now this is about the oscillator, this is about the amplifier, this which already we have studied in the unit 2 in a CE amplifier. Now for this, now amplifier we have drawn. Now what are the main blocks of oscillator? First one is an amplifier, second one is a tank circuit. Now tank circuit, here I can draw like this. Now here I am using, heading is Hartley oscillator. So Z1 and Z2 both are the inductors. Z1 and Z2 both are the inductors in parallel with the capacitor. Now output I am giving it to the feedback network. Output we have to give to the feedback network, and feedback network what it will do, it will take the fraction of the output and it will again apply at the input signal. Now here I am taking the ground connection. So I can take two grounds like this, or if I wanted to join these two together, now I can join these two together and make one ground connection, however you want it to. So you can show separately, or you can give a single ground connection like this. Now this is one way to draw the diagram. Otherwise, so now here in few textbooks or in the material I have given the tank circuit. Now here I am given the ground circuit. Now tank circuit I can also take here. So inductor I am taking, two inductors I am taking, and these two inductors are in parallel with one capacitor. Now output I am applying to the tank circuit or feedback network. This is the feedback network circuit. Now here I am applying the ground. So L1, L2, C. Now this is also another way to draw the diagram. So here this input should come from the tank circuit, and output we are applying to the tank circuit. Now this is nothing but a feedback network. In this feedback network we are using the two inductors and one capacitor. Now here I am applying the plus VCC. So whenever the switch, now whenever we switch on the supply, now here we are not giving any input signal, because oscillator itself a generator, it has to give the oscillations at the output with the DC. Now with this DC will be converted into AC signal, sinusoidal signal. Now this we are going to get at the output. So whenever we switch on this supply, then immediately random noise will be generated in the tank circuit. Now with the tank circuit, that random noise again will be applied again to the input of the amplifier, and amplifier will amplify. So here so many oscillations, so many harmonics are there that will be amplified, and again it will be applied to the tank circuit. Now this tank circuit will pick any one of the frequency. Now how it is charging and discharging, in the previous lecture I have explained. So capacitor charges and after that it will discharge through the inductor. So because of charging and discharging, now here the frequency F naught is equal to what can we write? It sets up the oscillations, and those oscillation frequency is 2 pi root LC. So now here, because of these two inductors are there and one capacitor is there, so when we connect inductor in parallel with the capacitor, then this acts like a tuned circuit, and it will give one frequency. That frequency is nothing but what? F naught is equal to 1 divided by 2 pi under root LC. But here we are using the two inductors L1 and L2. So where now here I have to take LTC, where LT is equal to L1 plus L2 plus 2M, where 2M is a mutual inductance. If in the problem, if the mutual inductance is not given, then you have to take it as LT is equal to L1 plus L2. If the mutual inductance is given in the problem, then at that time you have to use this. Now this is the frequency formula. So when the noise is generated, and that will be amplified by using this amplifier. So it will pick one frequency. That frequency is nothing but this frequency, and that frequency, now here if you see, this will charge and discharge through this L1 and L2. Now whatever the voltage drop across the L2 is fed back to the input of the amplifier. Now this is a feedback, this is the feedback signal. Now here whatever the voltage drop across this L2 is there, that is fed back to the amplifier, and again amplifier amplifies the signal, and again it will give to the tank circuit. Now thereby it will generate the oscillations, but it has to satisfy the two conditions. Condition number one is what? Magnitude of loop gain A beta is equal to 1. Now here we have to set the feedback signal such that the overall gain of this circuit A beta is equal to 1. And the second condition is loop phase should be 0 degrees or 360 degrees. Now already we know that this is the CE amplifier. CE amplifier produces the 180 degrees phase shift. Now whatever the signal you apply at the input, it will be phase shifted by 180 degrees at the we get the 180 degrees phase shift at the output, and this tank circuit is producing the one more 180. How? So here between L1 and L2, so we grounded here, thereby now here what if I am taking this is a 0.1 and this is a 0.3 and this is a 0.2. If the 0.2 is connected to the ground, then 0.1 is 180 degrees with respect to 0.3. Now if you recollect the center tapped transformer, so secondary is exactly taken center point and grounded it, thereby what? It will produce the 180 degrees phase shift. The same concept here also we can use. Now L1 and L2 both are connected in series. At center point, if we are here we need to maintain the same values. Here L1 and L2 should not be equal. We are using two inductors in between and connected in series, and the center point is we can say that where the two ends are joined, that end is connected to the ground, thereby it produces the 180 degrees phase shift at 1 with respect to 3 and vice versa. If we are measuring at 3 with respect to 1, it will produce the 180 degrees. So 180 degrees is produced by the tank circuit, one more 180 degrees is produced by the amplifier, thereby the total loop phase shift is 360 degrees. So it is satisfying the two conditions, thereby this electronic circuit, this circuit acts as an oscillator and it will set up the oscillations, and the frequency of this oscillation depends on this tank circuit values. Now here this is the frequency. So this is about the Hartley oscillator. Now similarly, and these Hartley oscillator, and we use this LC oscillators to produce the high frequencies. Now similarly, we have one more oscillator, that is the Colpitt's oscillator. Now there the complete circuit is same, only the difference is here we are using the, instead of two inductors, we are taking the two capacitors in parallel with inductor. In parallel with inductor or transformer. Transformer, why we have taken? Output we can take it from here, otherwise simply you can show one inductor. Now what happens here, whenever the switch is on, so here you can see RC we can take one resistor or one RF coil. So anything you can put over here to control or to control the load current. Now here when we switch it on, and because of the transient current or random noise, oscillations will set up in this tank circuit, and again it will tune to, now here what is the frequency, f naught is equal to, it will tune to one frequency, that is nothing but what, 2 pi root L C, but here two C values are there, so we have to take the CT. Now what is CT? CT both are connected in series, so CT is equal to what, C1 C2 divided by C1 plus C2. If capacitors are connected in series, then how to calculate the total capacitance? That is CT is equal to C1 C2 divided by C1 plus C2. Now this is the frequency, and here also same, the tank circuit is connected, how the tank circuit is connected in the Hartley oscillator, similarly here it is also connected. Now with respect to point 2, point 1 will produce the 180 degrees phase shift, and vice versa. With respect to point 1, point 2 will produce the 180 degrees phase shift, and one more 180 degrees phase shift is produced by the CE amplifier. So condition number 1 is what? So 360 degrees, it is producing total 360 degrees, and condition number 2 is A beta is equal to 1. Now here we have to arrange the capacitor, or we have to arrange the tank circuit values such that it is supposed to produce the A value is equal to 1 divided by beta, thereby what, total loop gain is equal to loop gain A beta is equal to 1. So if these two conditions satisfies, then it will set up the oscillations. Now output we can take it from here on here. Now when the capacitor, now here inductor is charged, and when it is discharging, now whatever the voltage across this C1 voltage is applied to the base of the transistor. Now from here we are taking the feedback signal. So this is same, operation is also same like a Hartley oscillator, and but the only thing is what, we are interchanging the L and C values in the tank circuit. So again this Hartley oscillator is also used to generate the high frequency signals, and to generate the low frequency signals. So by using this we can't generate the low frequency signals. Why? Because if you see, f is equal to what, f is equal to 1 divided by 2 pi LC. Now if the frequency is reduces, then the inductor value is increases, thereby the overall circuit size increases. So circuit is bulk in size, and also maintenance complexity increases. So that's why we can generate the low frequencies by using LC, but it is a little complicated, and circuit will size increases, cost increases, and noise will be produced. So that's why we go with the go with the components, using components RC, we will generate the low frequency signals. So that we will see in the next lecture.